So good morning to all. Uh, Today we will be discussing the components of embedded systems. So if you find a embedded system, what could be the possible components? So here we are discussing all the components that may require to build up a embedded system. So first of all, we'll be finding some core elements. That means some microcontroller within the embedded system, some sensors, actuators, and the memory. These are the core components of the embedded system. So each and every embedded system must have these four things. Then additionally, some peripheral components may be also present there. So core elements that enable the functionality of an embedded system is first one is the microcontroller. So these are sometimes synonymous to the brains of the embedded system. So it is basically a processing consists of processing core, memory, and peripherals on a single chip. So the basic difference between the microcontroller and microprocessor. So microprocessor is a standalone processing unit, whereas the microcontroller is the combination of some few amounts of memory, processing core, that is microprocessor itself, okay, peripherals on a single chip. Basically a microcontroller is a chip which is a single chip, okay, to execute basically the control task, the process, the sequence of process that might be executed by this microcontroller. So usually very small program that that is written in the memory, okay, and step by step one we're executing these instructions to basically execute a control task. That's a microcontroller. So this is the processor part. So within a microcontroller you will find a processor part, okay, some timers. So these are basically a you can say it's a microcontroller components or embedded system components like that. So it's a processor, timers, okay, so program memory and data memory, some serial communication port, parallel port, interrupt controller, output interfacing or driver circuit, input in device interfacing or driver circuit. Apart from these core components, you may have some system application specific circuits and power supply, reset and oscillator circuit that is required to give the power, as well as some synchronization clock, okay, to all these different components. So these are the components of the embedded system. Next part is the sensor. Sensor is to basically collect the data from the environment by sensing the physical parameter, maybe the temperature, light or motion, okay, vibration. Basically physical properties are getting converted into the electrical signal which can be processed by the microcontroller. Actuators is basically opposite thing. So you will supply the electrical signals to these components, and they will convert these electrical signals into the physical quantities. So such as motor opening a valve, thus executing the system's commands. So embedded system, whenever the commands give some commands to change some physical so whenever microcontroller is giving some instruction for some physical movement, okay, for example, to raise some temperature, to turn on some lights, to give some brakes or acceleration in the motion, okay. So these are just exactly opposite of the sensor. So actuators is doing those commands, executing those commands. And next core component is the memory. So memory components it consists of some volatile RAM or maybe non-volatile RAM like ROM, non-volatile memory, that is ROM, flash, etc. So it requires to store the program instructions or some operational data. Operational data means it may store some sensors output, or it may buffer the executing commands okay, at the actuator. So these are the memory, very small amount of memory required for the components of embedded system. So in short, if you are asked to provide the information regarding the components of embedded system is consist of microcontroller, memory, sensor, actuators. Okay, so we'll be moving to the next thing. So you need to remember this big picture of my embedded system that consists of some microcontroller, which may be of these basic blocks, okay, as well as some power supply, reset circuit, etc., input and output devices, interfacing, and some system specific application circuit. Okay. 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 Next part, we'll be discussing the architecture of embedded system. Okay. So architecture means basically a framework that defines the embedded functionality. So architecture may be of the hardware architecture, maybe of the software architecture, and in special case where the embedded system is applicable to the real-time operation. So in that case, essential or managing concurrent to manage the several concurrent tasks, we need to have the structure of the real-time operating systems. Okay, so in short, these are the architecture component of the embedded system. So regarding hardware architecture, it refers to the physical structure of the embedded system, maybe microcontroller, sensor, actuators, different interfacing modules for the input and output systems. To purpose is to achieve some specific functions. Okay, so purely consist of the different hardware part. Okay, so in the last slide we have seen the components of the embedded system. So basically we are referring the hardware component of the embedded systems. Okay, next part is the software architecture. So in software architecture, we need to consider the code specific for the application for which the embedded system is going to be developed or going to be designed. Software architecture, it also includes some library, okay, often that is called by the different software application, or some middleware that or device driver that basically enabling interaction and functionalities with the different input-output peripherals. Okay, next for the introduction of the real-time operating system. Actually, all the embedded system may not be a real-time operating system, but some of the embedded system that is designed for the real-time operation. So in that case, we require the real-time operating systems. So it is essential for managing the concurrent task. Okay, several tasks that has to be processed by the concurrently by the embedded system. Okay, and this case the real-time operating system, these OS operating systems are optimized for high responsiveness, low delays or low delays, where timing constraints are very critical, very crucial. Okay, timing constant, you have to meet the timing constant. There should not be any delay in executing the required functionalities. So real-time operating system, that architecture you need to have some ideas. Next part, we need to have the idea of types of embedded system. Okay, so these types that can be based on their functionalities or maybe some based on the connectivities. Okay, so to begin with, we are talking about the standalone embedded system. Okay, these are self-contained system that operate independently. Okay, it isn't connected with some other embedded systems. So some predefined task is already scheduled in the main processor or core. Okay, and without requiring any constant interaction with external device or network. Okay, standalone systems. Next part, we can differentiate the embedded system as the networked embedded system. So basically different embedded systems are networked in between them. They constantly communicate with each other, okay, by network, and they share the data and different control signals okay, among them. And next is the mobile embedded system. This is basically the target is for the portability, so it must be portable enough. So these mobile embedded systems, they are mainly very small and portable and battery powered, very small power consuming thing, and these are often maybe used to use along with the network embedded system. Okay, so based on this connectivity or functionality, we can classify the embedded system into three categories. So standalone embedded system, networked embedded system, and the mobile embedded systems.